Welcome to Lesson 8, Part 1 of our interactive notes. So Lesson 8, Addition using various algorithms for addition, pages 19 and 20. So we're going to work on 19 now, and then in Part 2 we'll be on page 20. So here's our lesson, our content objective, 4.NBT.B.4. So 4th grade, numbers base 10, B4, and this is a star because this is our fluency standard. I can add large numbers fluently. And then we also have 4.OA, so 4th grade, operations algebraic thinking. I can determine how reasonable my answers are by using estimation. Language objective, I can use vocabulary related to estimation and addition to explain my answer and to defend its reasonableness. Social objective, I can work with others to create a model to prove the sum is correct. Alright, so we have some vocabulary words. Addition, putting together, adding or combining, finding the total amount or sum. Addend, a number to be added to another. So the two numbers being added are both called addends. Sum, the amount found by adding numbers. So we often say it's the answer to an addition problem. So when you have your two addends or more addends added together, you find your sum. Regroup, to arrange into a new grouping structure. So these single units put together can be regrouped into a group of 10. Algorithm, a step-by-step process for solving a problem. So a step-by-step way of finding a solution. Here we have 7 times 3 is 21, and then 7 times 80 is 560 added together. So this is one way to be able to solve this multiplication problem, but it's not the only way. Identity property of addition. Talk about this every day with our daily fraction. 0 added to any number is still the original number. 0 does not add value. So any number plus 0 will end up staying the same. Associative property of addition. The way the numbers are grouped in addition does not change the resulting sum. So if I add these numbers, 35 plus 5 plus 1, if I add 35 plus 5 and get 40, then 40 plus 1 is 41. Or 35 and then 5 plus 1 is 6, 35 plus 6 is 41. Since they're all being combined together, it doesn't matter the order. Just like it doesn't matter the order students enter a room, as long as they're all in there at the same time, you get your total amount. Commutative property of addition. The order in which the numbers are added does not change the resulting sum. So 1 plus 3 equals 4, 3 plus 1 equals 4. Since they're all being combined together, it doesn't matter which one goes in first. It's the total amount at the end. That's what these both are dealing with. Alright, so here we're looking at 1, 2, 3 different ways to find a solution, 3 different algorithms for solving. First, we're going to start with our expanded algorithm, also called partial sums. So we line up, we always make sure they're lined up from the ones. And in this case, this is a little different because with the expanded algorithm or partial sums, we start from the largest place. So here we're going to add our largest place is 1,000, so this is where we're going to begin. So go ahead and circle that. 5,000 plus 4,000 is 9,000. So we have that down. Next, we'll go to the next largest place. We're going to add those. 600 plus 200 is 800. Now we're going to look at the tens place. So we already have our thousands place added together, our hundreds place added together. Now we're going to look at the tens place. 9 plus 7 is 16, but it's 16 tens. You can't put 2 digits in a 1-digit spot, so you have to regroup that one over to the next place. So you have 16 tens. Okay, so we have our thousands added together, our hundreds added together, our tens added together. Now we're going to add the ones place. 1 plus 4 equals 5. Once we have all of them added, all our partial sums together, now we're going to add straight down. And it should be fairly easy because 0 plus 0 plus 0 plus 5. 0 plus 0 plus 6. 0 plus 8 plus 1. And then just 9. So here we have just 5, 6, 8 plus 1 is 9, and 9. So our total sum is 9,965. So this is one way that we could do it with our expanded algorithm, also called partial sums. Here's standard algorithm with regrouping below. And I'm sorry, I had intended for these to be base 10 blocks, but they didn't copy very well. So this is 1,000. You can see enough to trace. So these base 10 blocks, or place value blocks, are representing. So I have 1,000, and if you see there's 2 hundreds here. One in front and one in back. Then there should be 1, 2, 3, 4 tens, and there should be 1, 2, 3, 4, 5 ones. So it represents 1,245. And then the next one we're representing 1,300. So there's 3 of those hundreds. They're stacked 1, 2, 3. 50, 1, 2, 3, 4, 5, 9, 1, 2, 3, 4, 5, 6, 8, 9. Okay. And so our number to begin with, we have 1,245, and then we line up in the ones. We line up in the ones. Now we do have the same amount of digits, but when we don't, if you don't line up from the ones, it ends up causing a problem. So being able to set up your problem is important. Writing it vertically. Now we're going to add the ones. So we have here, what we have is a regrouping that we're going to be doing. That's what the circle is showing. If you have 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 5 is 14, which is a 10, and 1, 2, 3, 4 ones. So I have a 10, which I'm going to regroup below, and 4 ones. So you can see that I have my 14. So the regrouping below lets you put the 10 still close by. So I have 14 ones. Okay. So that's what it shows here. Should have this. Sorry, it did not copy. And then we have the tens that we're looking at. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, because 4 plus 5 is 9. But this one needs to be included in here too. So we have a total of 10, which means I have another 100. 4 plus 5 is 9, plus 1 more is 10 tens. 10 tens is 100. So that regrouping below keeps that 10 with the ones place that I was talking about, the 10 tenths. Okay. Here we still have the 4 ones. We have all these hundreds, so we have 2 hundreds up here. We have 3 hundreds here, and the 100 here from regrouping. So 2 plus 3 is 5, plus 1 is 6. 2 plus 3 plus 1 is 6. No need to regroup here because we didn't have a 10. Okay. And then here, last we add the thousands. So we have our 4 ones. We have no tens. We have 6 hundreds. And we have the 2 thousands. So our final total is 2,604. So that regrouping below keeps that 10 and that 14 together. So those are 2 algorithms you may have seen before. 2 ways to get to the final sum, the total sum. Here is the standard algorithm with regrouping above, and this is the way that most people have, most adults learned to do addition. So here, again, we want to write it vertically, but our drawing represents that 1,000. 600, so there's 3 here, and there's 3 more there, so 600. And then 10, and then 3 ones. So there's my 1,613. And I have another 1,000. And 1,000's a cube because it's 10 times 10 times 10. 500, so there's 2 here, 3 here. 50. 1, 2, 3, 4, 5, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So these base 10 blocks are representing our numbers. We need to write them vertically. So my first add-in, I just go ahead and put on top. And then we want to make sure we line up from the ones. Very important. Now when they have the same amount of digits, it's easier to do, but when they don't, you've still got to make sure you're lining up from the ones, because otherwise you change the value of the number. So just like with regrouping below, we're going to start with our ones place. This is different than the partial sums. When we start from the ones place, we have 3 ones plus 1, 2, 3, 4, 5, 6, 7, 8 ones. 8, 9, 10, 11. We get a 10 and a 1. So this time we regroup above. So 11, we have 1 in the ones place and 1 in the tens place. And we regroup above the line. So here, now we're going to add the tens place. There's that regrouping above and below. So we had 1 10 and then 5 more. 1, 2, 3, 4, 5. So 5, 6, 7 tens is 70. No need to regroup. So now we're going to add the hundreds. We had our adding. We regrouped that 10. We added the tens. There was no regrouping. Now we're looking at the 600s plus the 500s. 600 plus 500 is 1100, so that would be 1,100. So 1,100. So we have to regroup the 1,000, and we put our hundreds down here. Okay, so we have that 100 171, and the thousands regrouped. So now we're just going to add those 3 thousands together. And 1, 2, 3, we get 3,000. So our final sum is 3,171. So now we're going to practice the 3 different ways. You do not have to do them 3 different ways. Choose the way that makes the most sense to you, that you like best, because I would rather you find a way that you will always get the right answer. That's the key here. Now on our 3-column notes, we will be practicing the different ways. And in some practices coming up, you'll need to practice the different ways. But when it doesn't tell you which way, choose the one that makes more sense to you. All right, now it's time for part 2 and our 3-column notes.